It's important to properly dispose of unwanted medication or sharps. MedProject offers free and convenient disposal options near you. To learn more, call 844-MED-PROJECT or visit medproject.org.
Celebrate Thanksgiving with Safeway. This week at Safeway, get whole Signature Farms frozen turkey 10 to 15.5 pounds for $8 each, or 16.1 to 22 pounds for $10 each. Member price with a minimum $50 purchase, limit one per household. Plus, packs of Coca-Cola, Pepsi, 7-Up, Dr. Pepper, or AHA Sparkling Water are buy two, get three free. Limit 3 free items. Also this week, get 5-pound bags of Signature Farms russet potatoes for 97 cents each with digital coupon. Limit 1. Visit Safeway.com or head in store for more details.
This is SpaceTime Series 25, Episode 32, for broadcast on the 16th of March, 2022. Coming up on SpaceTime, astronomers shocked by the nearest ever fast radio burst. Europe's CHEOPS spacecraft discovers a rugby ball-shaped exoplanet. And NASA's Perseverance Rover gets rocked on Mars. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
Astronomers have tracked a mysterious cosmic flash known as a fast radio burst down to a nearby globular cluster in a spiral galaxy called M81. The surprising discovery, which has been reported in both the journals Nature and Nature Astronomy, represents the closest fast radio burst ever detected, just 12 million light-years away. Fast radio bursts are sudden, unpredictable, extremely short flashes of light lasting just nanoseconds, but releasing more energy in that time than the sun does in an entire year. Several hundred flashes go off every day, and they've been seen all over the sky. The explosions occur at very specific wavelengths and usually at cosmic distances in the spiral arms of distant galaxies. So far, fast radio bursts have only ever been detected by radio telescopes. They were first discovered in 2007 in data collected by the Parkes Radio Telescope in the far west of New South Wales. Since then, hundreds more have been detected. The first bursts were all singular events, occurring just once at a specific location and then never again, and that suggested they were being caused by some sort of cataclysmic event such as a supernova or exploding star. But astronomers are now detecting fast radio bursts that have repeated from the same location, and that suggests a different cause. The leading contenders are highly magnetized neutron stars known as magnetars, but feeding black holes and glitching neutron stars haven't been totally ruled out yet either. Of course, it could simply be that all fast radio bursts are repeaters, with some repeating a lot more than others. The study's lead authors, Frans Kirsten and Kenzie Niemer from Astron in the Netherlands, set out to make high-precision measurements of a repeating fast radio burst first detected in January 2020 in the constellation Ursa Major, the Great Bear. They use multiple radio telescopes combining measurements from the European Very Long-Based Interferometer Network to obtain the highest possible resolution and sensitivity. These included radio dishes spread across half the globe in Sweden, Latvia, the Netherlands, Russia, Germany, Poland, Italy, China, and the Very Large Array in New Mexico. When they analysed their measurements, the astronomers discovered that this fast radio burst was coming from somewhere that no one had ever expected, a globular star cluster in a nearby galaxy. Globular clusters are tightly bound ancient stellar spheres containing thousands to millions of stars, all tightly bound together by gravity. They are much older than the less dense open star clusters which are found in the disks of galaxies. Many globular clusters are composed of stars that were all originally formed at the same time in the same molecular gas and dust cloud, while others appear to be the surviving cores of ancient galaxies that have been cannibalized by other galaxies through galactic mergers. Globular clusters are commonly found in the halo of galaxies. The Milky Way has at least 150 globular clusters in its halo, while Andromeda has an estimated 500. Nemo says it's amazing to find fast radio bursts coming from a place in space where you only find old stars. Further out in the universe, fast radio bursts have been found in places where stars are much younger. He speculates that this has to be something else. Many fast radio bursts have been found surrounded by young massive stars much bigger than the Sun. These are regions containing lots of core collapse supernovae, generated by the explosive deaths of stars far more massive than the Sun at the end of their lives. Big massive stars are sort of like the James Deans of the stellar world. They live fast and they die young, consuming all their nuclear fuel much quicker than smaller, more sedate stars like our Sun. When a core collapse supernova occurs, the core of the dying star is crushed into a dense stellar corpse, a neutron star, and these strange stellar remnants are the densest objects in the universe other than black holes. They pack more mass than the Sun in an object just a few dozen kilometers across. In fact, just a teaspoon of neutron star material would weigh billions of tons. Highly magnetized neutron stars are known as magnetars, and scientists have come to believe that fast radio bursts can be generated by these magnetars. The authors speculate that what they've found is something that had previously been predicted but never actually seen before, a magnetar that formed when another type of stellar corpse called a white dwarf became massive enough to collapse under its own weight. White dwarfs are the exposed stellar cores of stars like our Sun. When stars like the Sun run out of fuel and die, they lose their outer gaseous envelopes, which float away as planetary nebulae, leaving behind their now exposed white-hot stellar core, a white dwarf, an object about the size of the Earth, which is left to slowly cool over eons. However, a white dwarf in a tight binary system with a companion star can drag enough material off that companion star to eventually build up enough matter on its surface to trigger a thermonuclear supernova explosion, a blast powerful enough to completely destroy the star. But Kirsten says under the right conditions, instead of exploding, these white dwarfs may instead undergo accretion-induced collapse, turning into a neutron star. It's a rare occurrence, but in a cluster of ancient stars, it might be the simplest way of making a fast radio burst. The authors found that the fast radio bursts generated through this event were even shorter than expected, flickering in brightness within as little as a few tens of nanoseconds. Nemo says that suggests they must be coming from a really tiny volume in space, smaller than a soccer pitch, perhaps only tens of meters across. Similar lightning-fast signals have been seen from one of the sky's most famous objects, the Crab Pulsar. It's a tiny, dense remnant of a supernova explosion which was seen from Earth in the year 1054 in the constellation Taurus the Bull. Both magnetars and pulsars are different kinds of neutron stars. Some of the signals measured by the authors are short and extremely powerful in just the same way as some of the signals coming from the Crab Pulsar. Nemo says that suggested they might be seeing a magnetar, but in a place that magnetars haven't been found before. Future observations of this system and others will help them tell whether the source is really an unusual magnetar or something else, like an unusual pulsar, or even a black hole and a dense star in a close orbit. Whatever the outcome, it seems fast radio bursts are providing new and unexpected insights into how stars live and die. This is SpaceTime. Still to come, CHEOPS reveals an unusual rugby ball-shaped exoplanet, and NASA's Perseverance Rover gets rocked on Mars. All that and more still to come on SpaceTime.
Celebrate Thanksgiving with Safeway. This week at Safeway, get whole Signature Farms frozen turkey, 10 to 15.5 pounds for $8 each, or 16.1 to 22 pounds for $10 each. Member price with a minimum $50 purchase, limit one per household. Plus, packs of Coca-Cola, Pepsi, 7-Up, Dr. Pepper, or AHA Sparkling Water are buy two, get three free. Limit 3 free items. Also this week, get 5-pound bags of Signature Farms russet potatoes for 97 cents each with digital coupon. Limit 1. Visit Safeway.com or head in store for more details.
The European Space Agency's Characterising exoplanet satellite CHEOPS has discovered a strange rugby ball-shaped exoplanet. The planet, known as WASP 103b, is the first observed example of how gravitational tidal forces can deform a planet from the normal gravitational equilibrium which gives planets their usual spherical shape. WASP 103b is located some 1,800 light-years away in the constellation Hercules. It's a gas giant with around twice the size and has about 1.5 times the mass of Jupiter, the largest planet in our solar system. It's called a hot Jupiter because it orbits 50 times closer to its host star than Earth's orbit around the Sun. The planet's host star is a spectral type F white-yellow main sequence star called WASP 103, which is a little bigger and more massive than our Sun. The planet orbits its host star in just one Earth day and is deformed by the strong tidal forces so drastically that it appears to resemble a rugby football. If you're American, think gridiron football. On Earth, the tides are mostly generated by the Moon. Its gravitational pull causes the ocean's waters to accumulate in the region below it, generating a high tide, while the missing water in surrounding regions produces the low tide. And the tides follow the Moon as it orbits around the Earth, and the Earth spins below it. Although the gravitational tidal deformation of the ocean causes striking differences in level in many places, it's hardly recognizable from space. On WASP 103b, however, the tides are much more extreme. One of the study's authors, Jan Alibert from the University of Bern, says astronomers had already suspected that the planet's proximity to its host star would result in very large tides, but they hadn't been able to verify it. Eventually, the Hubble and Spitzer space telescopes, in combination with the high precision and pointing flexibility of CHEOPS, allowed scientists to measure the degree of tidal deformation imposed on the planet, despite it being some 1,800 light-years away. Scientists measured the planet's light curve as it transited or passed in front of the star, slightly dimming the star's light. The authors' results not only allowed conclusions to be drawn about the shape of the planet, but also about its interior composition. This is because the team were also able to derive a parameter known as the Love number, and before you get too excited, it's named after British mathematician Augustus Love. It uses the light curve data to indicate how the mass is distributed within the planet, and thus also gives clues about its interior structure. The resistance of material to deformation depends on its composition. On Earth you can easily see the tides on the oceans, but believe it or not, the solid ground moves as well, just not very much, so we don't notice it. Therefore, by measuring how much the planet is deformed, astronomers can determine how much is made up of rock, how much is gas, and how much is water. Launched in December 2019, the 273-kilogram CHEOPS was placed into a 715-kilometre high orbit. It's designed to measure the size of transiting exoplanets and to search for predicted transits of exoplanets previously discovered by way of the radial velocity or wobble method, their gravitational pull on the star as they orbit it. This report from ESA TV.
By searching beyond the skies, the Geneva Observatory is helping to answer questions about the nature of the universe we live in. In 1995 at the observatory, Michel Meyer and Didier Queloz co-discovered the first ever exoplanet orbiting a sun-like star outside our solar system.
In these days, I was using a technique that we call radial velocity, which is observing a star and looking for any change of speed in the star. Well, since then, the field has just exploded. As you may know, there is really now thousands of exoplanets. There are a lot of planets known to be transiting, which means the planet goes right in front of the star. And that's these techniques that we're using for the CHEOPS mission.
The CHEOPS Space Telescope can measure this tiny dip in light from the star during the transit.
CHEOPS's aim is to measure the size of already known exoplanets. So it's not a discovery mission. It is really aimed at precisely measure the size. And once we have the size and possibly the mass, we can derive the mean density. And from then we know a little bit what the planet is made of.
The exoplanets observed by CHEOPS are typically small and range from rocky and hot to gaseous like Jupiter, with possible Earth-like planets in between. Many have been discovered at much closer distances to their host star than those in our solar system, some taking just a few days to complete an orbit. There are differences too in how today's search for exoplanets is conducted, with space-based facilities complementing ground-based telescopes, and racks of computers to process data from targeted stars and exoplanets. The observatory also houses the CHEOPS Science Operations Centre.
We're sending the observation program to the Mission Operations Center in Madrid, where then the information is uplinked to the actual instrument. The instrument is configured to observe the star, and then the telemetry, the data is downlinked to the Mission Operations Center and right away forwarded to us here in Geneva, where we then can do the data processing, archive the data, and then provide it to the scientists all over Europe and to the world.
The compact Science Operations Centre at the heart of the mission also reflects the compact size of CHEOPS' telescope. It is just 1.5 metres long, but will punch well above its weight and size. There are now over 4,000 known exoplanets and counting, and through repeated observations of several hundred of them, the mission will provide an important insight into the inner structure of exoplanets, how they form and evolve.
And in that report from ESA TV, word from CHEOPS Science Team Chair Didla Quiers from the University of Geneva, CHEOPS Principal Investigator Willy Benz from the University of Bern, and CHEOPS Ground Segment Manager Matthew Beck from the University of Geneva. This is Space Time. Still to come, NASA's Perseverance Rover gets rocked on Mars, and lots more Starlink satellites have just been launched by SpaceX. All that and more still to come on Space Time. NASA's Mars Perseverance Rover has successfully caught and extracted its 7th sample of rock for eventual return to Earth. The car-sized 6-wheeled rover, which landed on the red planet's Jezero crater just over a year ago, is exploring the region's geology and searching for signs of ancient microbial life. While the latest sample collection went smoothly, it appears sensors detected an anomaly during the transfer of the drill bit back into the rover's carousel. The issue caused Perseverance to halt the caching procedure and phone home for further instructions. Mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California, say the anomaly occurred during coring bit drop-off when the drill bit, with its sample tube and just cored sample nestled inside, is guided out of the percussive drill on the end of the robotic arm and into the bit carousel on the rover's chassis. Sensors on the rover detected increased resistance during this process, and mission managers quickly requested additional information and data, as well as imagery, to get a proper idea and understanding of what's going on. The images showed that some grit and dirt had somehow fallen into the bit carousel. It seems these were fragments of the cored rock sample that had fallen out of the sample tube during the coring bit drop-off, preventing the drill bit from seating completely in the bit carousel. Mission managers will now need to undertake a debris removal procedure to ensure the pebbles are removed in a controlled and orderly fashion. Meanwhile, mission managers have also spotted a large rock which has somehow become jammed inside one of the rover's 6 wheels. The rover's front left hazard avoidance camera A spotted the rock during a survey of the rover's immediate surroundings. The hazard cameras help evaluate issues in front and behind the rover, like large boulders, deep trenches or dunes. Cameras create 3-dimensional views of the surroundings, which help the rover make its own decisions without needing to call mission managers for help. Based on the images, it seems the rock's been lodged there for several days. Now, it doesn't appear to be causing any damage or hindering the rover's operations, so it's assumed that it's not wedged in tight, and it should eventually fall out during normal operations. It's not the first time this sort of thing's happened. Perseverance's sister rover Curiosity, which is exploring nearby Gale Crater, has also had a rock stuck in one of its wheels for a while, which eventually fell out on its own. NASA thinks the rovers get the rocks stuck in their wheels as they're traversing slopes. They can also get in there as the rover moves over loose and broken terrain, and a bit of the rover's weight breaks the rock further into pieces, which then fling off and occasionally get caught in one of the wheels. The car-sized rover is now halfway through its primary 2-Earth-year-long mission, but it's expected to well and truly exceed that. Its twin Curiosity had its primary mission set at 687 Earth days, but it's now been active on the red planet for over 9 years. Perseverance and its sidekick, the Ingenuity helicopter, are now heading for a dried-up river delta full of sediment which has been washed out from further upstream. An ideal place to find geological samples, and possibly also signs of ancient microbial life, if it ever existed on the red planet. This report from NASA TV.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance Rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
This is SpaceTime. Still to come. Lots more Starlink satellites launched. And later in the science report, a new study finds that heterosexual transmission of HIV, that's the virus which causes AIDS, is more deadly than homosexual transmission of the virus. All that and more still to come on SpaceTime. SpaceX has been busy with 3 more launches of Starlink broadband internet satellites from opposite ends of the United States over the past 2 weeks. The intense campaign started with a Falcon 9 rocket carrying 50 of the 260-kilogram spacecraft into orbit from the Vandenberg Space Force Base in California in late February. The first stage then successfully returned to Earth, landing on a drone ship pre-positioned downrange in the North Pacific Ocean. That flight followed the loss of some 40 Starlink satellites on a previous launch after solar winds from a geomagnetic storm increased atmospheric drag on the spacecraft, causing their orbits to decay before they could be lifted into their final operational positions. Just a week after the Vandenberg launch, another Falcon 9, this one carrying a further 47 Starlink satellites, was launched, this time from the Kennedy Space Center at the Cape Canaveral Space Force Base in Florida. This mission marked the 11th flight for the same Falcon 9 core stage, which then successfully returned to Earth, landing on a drone ship pre-positioned downrange in the North Atlantic Ocean. And that was followed just 6 days later by yet another launch from Cape Canaveral, this time sending 46 Starlink satellites into orbit on a Falcon 9. This now brings the total number of Starlink satellites launched into space to 2,282. Eventually, SpaceX hoping to have a constellation of some 30,000 Starlink satellites orbiting the Earth. And that's causing major concerns for astronomers who are finding the trains of Starlink satellites damaging their important scientific research, a problem which is only going to get worse as more and more Starlink satellites are launched. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. The Amazon rainforest, long considered the world's lungs, may be reaching a point of no return. A report in the journal Nature Climate Change warns that the planet's largest rainforest is now reaching a tipping point where the woods will be lost, replaced by savanna. Scientists believe now more than 3/4 of the rainforest is losing its ability to bounce back from disturbances over the past 20 years. Scientists using satellite remote sensing data looked at changes in the rainforest resilience between 1991 and 2016. They found that 75% of the rainforest has lost its resilience since the early 2000s. The authors say this puts it at risk of dieback, an irreversible cycle of collapse. A new study warns that heterosexual transmission of the human immunodeficiency virus HIV, that's the virus which causes AIDS, is more deadly than homosexual transmission. A report in the journal PLOS Pathogens has discovered that HIV infections seem to be more severe when transmitted by way of penile vaginal intercourse, with the virus remaining fitter when transmitted through this method. The authors reached their conclusion by analysing T-cell counts from over 340,000 HIV-positive people who are either exclusively gay or exclusively straight. The authors found the infections transmitted by way of penile vaginal intercourse correlated with lower T-cell counts than gay transmission, suggesting more severe or virulent strains. Paleontologists in China have uncovered a new species of stegosaur dinosaur, the oldest ever found in Asia. The new species, called Bashanosaurus primitivus, is named after an area of China where the dinosaur was found. The fossilized remains suggest the giant herbivore was some 2.8 meters long. A report in the Journal of Vertebrate Paleontology suggests the new dinosaur, which roamed the planet 168 million years ago, had armor plates with a narrower and thicker base than other Stegosaurus dinosaurs, and had similarities with some of the very first armored dinosaurs, which are over 20 million years older. Apple have launched their new Mac Studio and Studio Display, as well as a new iPad Air, a new iPhone SE, and iPhone 13 and 13 Pro in 2 new shades of green. With the details and more, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
Apple had its March launch dubbed Peak Performance, P-E-E-K, because we were peaking into something. And there were lots of rumours, but ultimately what Apple launched was the new iPhone SE 3 using the same sort of design as the iPhone 6, but with the latest A15 processor and 5G. That's the sub-6 gigahertz 5G, which is the regular 5G, not the millimeter wave. The millimeter wave 5G is only available in the US to buy on an iPhone. In Australia, we do have some sites with millimeter wave 5G, but only certain phones like the Google 6 Pro have it. And there might be some other phones out there, but it costs extra for companies to do that. And whilst there was some disappointment expressed on the internet that Apple's iPhone SE3...
Everyone thought the iPhone 13 would have all that.
Yeah, they did. I did. Hopefully the iPhone 14 will have millimeter wave 5G in Australia. But at the moment, it's only the American iPhone 13 Pro and 13 Pro Max have it. But in Australia, you do have phones like Google 6 Pro. Now, they also launched an iPad Air with 5G and this time an M1 processor. I thought Apple might do that because clearly when they launch the next iPad Pros, they will put more powerful M-series processors inside, and that leads me on to the M1 Ultra. Now, Apple last launched successors to the M1, being the M1 Pro and the M1 Max, based on the original M1 architecture, but with more cores and more neural processing units and all the rest, and they had something called the M1 Max, which was a much more impressive chip than the M1. And those were only available in the MacBook Pro 14 and 16 inch. But now they have something called the M1 Ultra, which is two M1 Max chips bonded together using what Apple is calling Ultra Fusion technology. It's a kind of similar to AMD's Infinity Fabric, which allows you to join chips together in a way that is preserving their speed. And with the M1 Ultra, apps think of it as one giant chip, not as two separate chips. And so this is sort of the most powerful processor you can get in the Mac, and it competes very strongly with the best chips from Intel and AMD, but it has up to between 100 and 200 watts lower power draw. And whilst it does have a very impressive fan system inside, for the most part you won't hear the fans. But I read about computers like Dell XPS 15s and the latest Microsoft Studio laptop with a screen that can fold up and down and turn into like a tablet, more or less for drawing things on the front of it, with the screen coming over the keyboard as opposed to the screen being pushed back downwards. And the review that I read talked about that having fans that sound like a jet engine. So, most of the Apple Mac computing experiences are going to be silent. I know that on a Windows device, simply fire up Windows Update, the fans go to maximum. And that's just for stock standard boring old updates. And if you're doing Zoom, the fans start spinning wildly.
I had that same problem with my old MSI laptop. As soon as you turned it on, the fans went to max, and there was no way to change that. Or sometimes it happens. And you can hear it, especially when you're recording.
And if there is a way, that's right. And if there is a way to change it, then you find that the performance of the processor is cut down tremendously. If you are a content creator, it's much better to be doing things on a Mac, especially a MacBook Air, which has no fans at all. But for the everyday sort of standard content creation stuff you'd be doing, that would normally make a Windows PC's fans spin wildly. But on a Mac, you either don't hear the fans or they're extremely quiet if you have a computer with fans, and you really have to be pushing it. So Apple has this new Mac Studio. It looks like a Mac Mini that's about 2 or 3 times the height. It's got all these ports on the back of it, and it's the only computer at the moment that has the M1 Ultra inside of it. Apple did also talk about the Mac Pro, which is something that at the moment has Intel Xeon processors inside. The M1 Ultra is more powerful than the Mac Pro. Now, the Mac Pro will probably end up with a computer that has 2 M1 Ultras inside or something like that. They might even launch the Mac Pros with the M2 processor, which would be a successor. But at the moment, Apple has the M1, the M1 Pro, the M1 Max, and now the M1 Ultra.
That's Alex Zaharov-Reutt from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.